Hey everybody, this is Mr. Piercy, and today we're going to be looking at a couple of trig ratios associated with right triangles, the sine and cosine function. Now in a previous video I've talked about tangent and given some information about sine and cosine, but today we're going to be uh, focusing specifically on what sine and cosine are going to be used for. Now here we have a couple of vocabulary terms. Sine and cosine, we're going to get into those a little bit more detail on the next page. But one of the things that we're going to be looking at with trigonometry in general would be the angle of elevation and the angle of depression. Now, most people do okay with this as long as they remember that angle of elevation and angle of depression are always going to be made from a horizontal line. So if you're following along with your notes, oh, pay no attention to the bell there. If you're following along with your notes, please make sure you copy down the diagram to show what an angle of elevation or an angle of depression is. And notice that they're always going to be inside of an angle made with a horizontal line. Oftentimes people will misconstrue, particularly an angle of depression. They'll look at the angle of depression kind of being out here somewhere when it really should be inside of the angle that you made with a horizontal line. Okay, so make sure you have the vocabulary copied down and get the uh, diagram added to your notes as well. Now let's take a look at sine and cosine. In the video where I talked about the tangent ratio, I gave the acronym SO, CA, TOA, where tangent was the opposite side over the adjacent side. That's how we read the acronym. Well, sine and cosine are found the same way. Sine is the ratio of the opposite side to the hypotenuse of the right triangle, and cosine is the adjacent side of the angle to the hypotenuse. So here I would say sine of my angle, sine of theta, is equal to the opposite side over the hypotenuse, and cosine, and let me just give myself a little bit more room here. Let me just take that out for now. So cosine of theta is equal to the adjacent side over the hypotenuse. That's how we're going to set up our ratios whenever we're trying to find missing sides or angles of right triangles using sine or cosine. Now, just like what we talked about with sine, or I'm sorry, with tangent, the opposite side and the adjacent side change relative to where the angle is. So, for instance, let me pick a different color here. If we're saying sine of A, we're looking at here's my angle of reference. So the side opposite of angle A is this side CB, and the hypotenuse is there's the side obviously across from the right angle. But here I could also say, what's the sine of C? So we can change our location, our reference angle can change. So here, the opposite side in this case would be segment AB. So I can say the sine of C would be AB, hello email, over the hypotenuse AC. And we could do the same thing with cosine. Sine and cosine, again, the angle of reference will change depending on where your acute angle is. So here, let's do purple, I guess. Again, if I'm looking at here that we have the cosine of A, so what would be the cosine of C? Well, the cosine of C here, if that's my reference angle, the side adjacent to the angle that's not the hypotenuse is side BC, but the hypotenuse is still just AC. And I want you to notice here the cosine of A and the sine of C are the same, whereas the sine of A and the cosine of C, those are the same. That, if you recognize that connection where one, the sine of one is the cosine of the other, it could help you just, be a little bit more efficient in setting up and solving your equations. So here, this is just Can you identify the appropriate sides to identify the opposite side or the adjacent side and put it in a ratio with the hypotenuse, whether we're looking for sine or cosine? So here, looking at the sine of u, we're going to say the sine of u is equal to the opposite side over the hypotenuse. So the opposite side of u, in this case, is going to be side wv, and the hypotenuse is uw. Substituting the values in this case, we would get 16 over 34, which simplifies as a fraction. If you can simplify your fraction, you really do need to. And we wind up with that 4 decimal place number that we saw with our tangent ratios, 0.4706. Now remember, those decimal values, those were used to create trig tables for people that didn't have calculators to find out what those ratios were really easily. They would just look it up and say, oh, it's this, and then they'll do the math with that rounded decimal number. For us, most of the time, we're going to just leave it as a fraction, and we're going to say that's the ratio that we're looking for and not go with the decimal value. So now looking for the sine of w, again, the reference angle is changing, so now w is our reference angle, so the side opposite of that is going to be side uv, and the hypotenuse is still the hypotenuse. Substitute the values, simplify your fraction, and the associated decimal value rounded to 4 decimal places for our trig table, 0.8824. But again, for us, we would be more interested in what the actual fraction would be rather than the corresponding decimal number, because we would prefer to work with exact numbers, which is what the fractions would be, rather than a rounded decimal number whenever possible. Here, same concept where we're finding the cosine of some angles, cosine of the two angles of this particular right triangle. So again, we're looking at the adjacent side and the hypotenuse, and these are going to be set up the exact same way. We just have to recognize what side is adjacent to the angle. Remember, the hypotenuse looks like it's adjacent, but hypotenuses can never be adjacent or opposite. They're always going to be considered just a hypotenuse, where the two legs of the triangle are either opposite of an angle or adjacent to an angle. So in this case, we would say 45 over 53 is the exact value, or 0.8491 is the rounded answer. And same thing here. When we move our angle of reference, our adjacent side changes to be RT, but the hypotenuse stays the same. So we wind up with 28 over 53. Here, it's asking you to find all 4 ratios, sine for B and C, and sine for B and C, or cosine for B and C. So go ahead and pause the video and find the 4 ratios here. And when you're done, go ahead and hit play. Come back and compare your answer with mine. All right, hopefully we have a good answer here and see what we come up with. So we're just looking for for our ratios here. Now, where did I wind up putting my answers? Let's see. Here we go. So sine is just opposite over hypotenuse. So the sine of B in this case is 21 over 29, which that is what we would really prefer as our answer. And sine of C is 20 over 29. Cosine of B is 20 over 29. And again, cosine of C is 21 over 29, making, again, the fact that these two are the same and these two are the same. And again, remember, we would actually prefer the fractions as an exact answer as opposed to the rounded decimal numbers, because we have calculators that can keep the exact numbers to a much higher degree of accuracy than 4 decimal places. So now we're going to be kind of giving an application for how we're going to use a trig ratio. Now here we have a basketball court, and we want to go from one corner of the basketball court to the other corner, because obviously that's going to be shorter than walking all the way around the perimeter along the, where the back of the rim is and along the sideline. So we're going to set it up by saying, well, let's find the hypotenuse in this case. Well, looking at the angle of reference that we have here, let's see, what color do I have? Let's go blue. Here's my angle of reference. So the side that I know, this is my side opposite of the triangle, and the side that we're looking for, the distance that we're going to walk, this is the, oops, I wrote that as a B. This is the hypotenuse. So we know the hypotenuse, or I'm sorry, we know the side opposite of the angle, and we know we're looking for the side of the length of the hypotenuse. So opposite and hypotenuse, that lets me know we have to use the sine function. So here we're going to set it up, and this should really say theta, sine of theta, is equal to the opposite side over the hypotenuse when we set up our ratio. Then we substitute our numbers, so we substitute 62 for theta and 94 in x for the opposite side in the hypotenuse. Multiply both sides by x to get it out of the denominator, and I'm going to up with x multiplied by the sine of 62. Then divide everything by the sine of 62, so that way we can get x by itself. Now remember, what they're asking you to do is says take the sine of 62. What is that as a fraction, or what is it as a 4 decimal number back up a little bit. Sine of 62, they're looking at it to be a 4-digit decimal number. There we go. I knew I could get it out eventually. But we don't need to actually put in that 4-digit decimal number. We are going to just type it into the calculator exactly like that, where I'm going to say 94 divided by the sine of 62. Now again, if you're watching this without having seen the tangent stuff from previous, on your calculators, depending on the kind of calculator that you have, there's two dominant types of angle measurements that we use. Degrees, everybody's very familiar with, 0 to 360. But remember, a radian is just a different way of measuring an angle. And 1 radian, the way that we define it, 1 radian is, if I take the length of the radius and I lay it along the circumference, the angle that's formed here, this is 1 radian. And you need to make sure that your calculator is set into degree mode as opposed to radian mode, because that's the type of angle that you're entering into the calculator. So 60, or when we say 94 divided by the sine of 62, if you're in degree mode, you're going to get 106.5 almost. If you're not in degrees, if your calculator's in radians, it's going to give you something completely different. So here, taking a look at this example, again, this is where we're going to use the information, or the, not the information, but the vocabulary terms, angle of elevation or angle of depression. So we have in this example, a roller coaster where we're at the top of the roller coaster. So you're looking horizontally at the top of the roller coaster, and then you go down. So that 44-degree angle, that's going to be representing an angle of depression, and you're up 100 feet in the air. Now you can recognize that the angles here are going to be complementary, so you could find that angle here, and you could also say that this angle here is going to be 44 with alternate interior angles, but just make sure that when they're saying angle of the depression, that you have to go with a horizontal line, then draw your line diagonally down, and the angle of depression has to be in between those two lines. So again, when we set it up, this should really say sine of theta is equal to the opposite side over the hypotenuse. Then you substitute your numbers. So the angle in this case is 44. So the opposite side is 100 over x, or 100. The hypotenuse is x. And we're going to solve this one identically to the way that we did the last example. Multiply both sides by x, so I get x times the sine of 44 is equal to 100. Then divide everything by the sine of 44, and just type that into your calculator, making sure that your calculator is set to be in degree mode. And when you say 100 divided by the sine of 44, you're going to get the length of that drop to be about 144 degrees, but I'm sorry, feet. But remember, for pre-AP and AP math, we're rounding it out to 3 decimal places. So you know what to do at this point. Go ahead and pause the video and work out these next 2 examples, and when you're done, hit play again and see how your answers look compared to mine. All right, so here in example 3, use the cosine ratio to approximate the width of the basketball court. So here, For some reason I thought I had a picture here, but I guess I didn't leave the picture here. But here we're going to look for the cosine ratio. If you need to see the picture, go back to example 3 and look at it. And we're going to say the cosine of the angle is equal to the adjacent side over the hypotenuse. So in this case, the width of the basketball court, in this case, would have worked out to be almost 50 feet, 49.981. Here we're looking back at the roller coaster. Suppose that the angle of depression is now 72 degrees, and somewhere there we go. I don't know why it's all the way down there. Somewhere, there we go. The angle of depression in this case would be 72 degrees. So we're looking to see how far would it go down. So the sine of theta is equal to the opposite side of the hypotenuse. Substitute your numbers, do your math, and the drop would have been about 105 feet, but we'll put the 0.146 for pre-AP and AP rounding purposes. Next, moving on here, find the lengths using an angle of elevation. So last question kind of talked about angle of depression, so now we're looking at angle of elevation. Angle of elevation usually students do much better at for some reason. It just seems much more intuitive that we're looking forward and then we look up to make the triangle, and so that the angle should be in between the horizontal and the diagonal line. So we want to find the value of how high is the top of that railroad crossing sign from the horizontal at where Y is. So let's take a look and see how we're going to do this. So find X. So X, based off of the angle that we're looking at, is the opposite side of the angle. And the 20 feet would represent the hypotenuse. Opposite and hypotenuse tell me I'm going to be using sine. So that says sine of theta is equal to opposite over hypotenuse. Substitute your numbers. And now multiply both sides by 20. And I would say 20 is equal to, or X is equal to 20 times sine of 35. Type that just into your calculator, and you'd say X is about 11.472 feet. Then you can find Y using cosine, since Y is the side adjacent to the angle. So cosine of theta is the adjacent side over the hypotenuse. Substitute your angle and your hypotenuse again in this case, and we get cosine of 35 is equal to Y over 20. Multiply by 20 again, and we get 20 times the cosine of 35. Type that just like it's written into your calculator, and we would say that the length of the horizontal side of that right triangle would be just over 16 feet. Now we saw something like this with tangent also, where we were looking at special right triangle, 30, 60, 90 triangle. And here it's just kind of showing you what the ratios for sine and cosine are going to be. Now if you don't remember, the rules for 30, 60, 90 triangles are that and that's kind of what this ratio here is kind of showing you, that the short leg, not the short leg, but the long leg is equal to the short leg multiplied by the square root of 3, and that the hypotenuse is equal to the short leg times 2. So taking the values that we have here, sine of 30 degrees, so my 30 degrees is on the right side, so the side opposite of that is 1, the hypotenuse is 2, so we plug that in for the opposite and hypotenuse, and we say 1/2 or 0.5. Cosine of 30, the adjacent side to 30-degree angles is the radical 3. So when I say the adjacent side over the hypotenuse, I say radical 3 over 2, or about 0.8660. Now again, that decimal number, that 0.8660, is never really going to be used. We really want the radical answer as an exact number, because those are going to be things that we'll actually use to create a unit circle, which is a very significant part into a trigonometry process, or in a trigonometry class. So here, again, last two examples, go ahead and answer these on your own, and when you're done, come back and hit play and see how your answers look compared to mine. Alright guys, so in example 5, we're changing the angle of elevation, and again we're just finding x and y. So when we're just repeating the exact same process that we did before. So here, to find x, we're still going to use sine, and that gives us a value of almost 13, so that's 12.856. And then we're going to do cosine to find y, and that gives us about 15.321 for y. And again, use the special right triangle to find the uh, sine and cosine from the 60-degree angle. So here we can use kind of the same information that we had from the previous one, but the ratios should work out to be the same, where we have radical 3 over 2 and 1 over 2 for our ratios. And again, we're definitely going to be more concerned with the fractions, even though we have radicals in our fractions, as opposed to the decimal numbers for future math classes where we do really more in-depth trigonometry. So that's going to wrap it up here for sine and cosine. Remember, sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And opposite and adjacent will naturally change depending on which acute angle you're using. Okay? If you have any questions about anything that you've seen here, by all means, let me know. I'll be happy to help you out. But until next time, ladies and gentlemen, thanks for watching and take care.